participants starting to come in. I'm going to leave it maybe 1-2 more minutes just to see how things climb. Say hello, let you know I'm here, and that every 15-20 seconds I shall have to keep saying that so all the new people know that we're not just standing here in silence. Okay, so we're going to kick off in a minute or so. I'm just letting the last few kind of participant counts climb. I'm watching it go up. So just to let it stabilize, I'll be with you in about 30-40 seconds. Okay, and for the last time, like I say, I will be kicking off in about half a minute or so. Welcome, glad to have you all on board. I'm just waiting for the last few folks to arrive. Okay, excellent. So anybody who is still joining us is going to miss the first few seconds, but I'm sure they will be okay with that. So quick mention of logistics. Firstly, this session will be recorded. So if you miss anything, have to pop out, you can find a recording later. We'll share that with all registered trainees, including the ones who aren't here at the moment because they have other commitments. So if you have colleagues, they're still able to register. We'll still send the videos if you let them know about it. Questions are very much welcome as we go. This is a webinar, so you can't unmute your microphones, but you have a question system and there's a chat system so you can talk to the moderators and they'll let me know what's coming through. I will also solicit questions at the end, but I'm absolutely happy to take questions as we go so the questions can be kind of directly relevant to what's on the screen. And finally, if you would like a copy of the slides, either to keep or to follow as we go, you'll find that on the link that is on the screen here and is also currently in the chat so you can find it. I usually start training with a short biography. This is as much as anything else for you to have some idea of how I have made my kind of technical journey and so that you can examine the sort of prejudices I bring with me. Most of my prejudices come from the fact that I have been heavily embedded as an engineer and that I don't do a very great deal of enterprise software. So just to give a quick summary, I joined ST Microelectronics in the late 90s, very late 90s, where I joined a toolset team as the real-time operating system engineer. And at that point in time, operating systems were actually bundled as part of the toolset, essentially deeply integrated with the C library. But time passed, and as the set-top box industry, which ST were involved in at the time, kind of switched from custom RTOS to GNU Linux, I followed along. And during the following sort of 15 years, I worked pretty much anywhere you can in set-top box software, with the exception of the security team. And during that period at ST, I was heavily involved in kernel engineering from various bits of time to time, but never upstream. All that was in-house vendor kernel development. I joined Linaro in 2014, initially in the kernel working group, where I worked on trying to improve some of the debug technology, and then later as the tech lead for the support and solutions engineering team. And my work in Linaro is pretty varied, but all of it will eventually trace back to those roots that I have in operating systems. So whether I'm kind of training, whether I am doing technical support for people, whether I am acting as an upstream maintainer, you can trace all of that back to that heritage I have in operating systems throughout my career. So that's where I've come from. That's the prejudices and baggage that I bring with me. And with that out of the way, let's talk about upstreaming. So to start off with, I'm just going to give a quick overview of what upstreaming is. Some of this is philosophy, some of this is just thoughts about what it really means. And firstly, the name going upstream. The reason we talk about going upstream is that the view of the world is that normally code flows downstream from developers through projects and perhaps through products to users. So that's the downstream delivery. It starts from the developers and ends up with the users. When users or intermediate developers in the chain give code back from the place it came, that code is called going upstream. So when we put code back into Linux to support certain things, that code is traveling upstream. It is not flowing downstream from the original developer to the users. And this is an important slide because it brings in some of the philosophy, hence the rather strange yellow background. This is two different possible definitions of upstreaming. The first, that upstreaming is the process of moving code from downstream vendor trees to the top level Linux repository maintained by Linus Torvalds. That's a very functional description of what upstreaming is. That might describe our goal. Our goal with upstreaming is to get code into the Linus Torvalds kernel. But there are other ways we could think about what upstreaming is. And here I have a second definition, bottom right, that it's a process of technical and social influencing with the goal of persuading a kernel maintainer that it is better to include the changes you've proposed than it is to ignore them. Now, this is a very harsh way to describe what upstreaming is. You've simply got to exert technical and social influence to persuade somebody else to apply a change to the kernel for you. And that's a very strong description of how. That is how you upstream. You upstream by performing that technical and social influencing process. And most of the rest of today, and indeed next week, are all about how to become the strongest technical and social influencer that you can be. So we'll start with what upstreaming is, what it looks like. This is perhaps a very simple, practical, pragmatic description of what upstreaming truly is. This is a patch set prepared by one of Linaro's developers. It's been through multiple versions already, which is why it's got a version number, to enable display and CPU clock management for a particular Qualcomm part. And it is literally sending emails. So this is what we call the covering letter. It's a email that you send as part of a set of patches that describes the purpose of the set as a whole. And in this case, the set is very simple because it's described entirely by the subject. It is a display and GPU clock enablement. I say simple. The description is simple because it's not doing anything more than enabling a piece of hardware. So there isn't actually description in the letter, but we do have change logs describing all the things that have changed as the patches have been modified. So going back to that, there are other emails in this chain. So I'm going to pick the third one because it gets some replies. Actually, no, I'll do the first. So the other thing we get, another email requesting a particular change. In this case, it is to replace the power domain integers with their respective defines to make the thing more legible. So this is a preparative change to make this particular device tree fragment more readable, ready to make other changes later on. And you can see it's been split out. It's a very small change. And there are several other changes as we go through. In particular, we have this patch, which is to add device tree bindings for the clock controller. And again, it introduces a new file. And here we have a reply. So the reply that we get, thread overview, is from Rob Herring, which is a code review. Very, very simple code review. It consists of 2 words, dual and license. Although that's everything you need to know. That tells you that this license here, the GPL 2.0 only, is insufficient because device tree bindings are required to be licensed by another license as well, so that they can be used by the BSD Linuxes as well. And Robert has provided an equally concise reply, hack, which means I thank you for sending the feedback and I will fix it. So it can be very, very terse environment. It's not always a terse environment. It can also be, these are just emails. Emails are for communicating. Chat happens via emails as well as anything else. But in this case, the conversation is quite functional. And I think Rob's other reply here is a reviewed by, which is to say, thank you for sending the patch. I think it's ready to go in the kernel now. So that's one very literal description and demonstration of what upstreaming is. This is also upstreaming. So what this is a email sharing the minutes of a private meeting about how to implement Intel's advanced matrix extensions. The advanced matrix extensions made some fairly significant changes into the way I think context switches had to be handled in the kernel, certainly to make the context switching as optimal as possible. And it was somewhat controversial. You can see here, this is a minutes to a version 10 of the patch set, which was still creating some controversy. If you're interested in the exact lengthy nature of the controversy, you can read the LWN article linked at the bottom. But to be clear, this is also upstreaming. This is a form of consensus building. So by having that private meeting, there were ideas expressed, and that's not sufficient. They still have to bring the rest of the community along with them. They have to have consensus from other stakeholders in the Intel ecosystem. So they shared the minutes. They shared the minutes of what they think they need to do to get the code ready to be shared. They publish those minutes. Others can read them. They can argue if they wish. They can debate. But through this process, they're gathering consensus. And so this communication, this is clearly just communication, just an email. This is also upstreaming in exactly the same manner that these functional patches are. It's just that in this case, the goal is consensus building so that reviews go more smoothly next time. So why would we go through the upstream processes? Firstly, we might be looking to reduce costs. So the sort of costs we can be reducing are classically sharing support effort. If you have upstreamed code, particularly if you're a stock vendor, then other ecosystem players, which we can call the community, invest in understanding how your upstream code works. They add new features, they integrate it into products that you might not have had in mind or your salespeople might not have been chasing. We can gain access to a wider ecosystem of software. So it's very common in the embedded world to provide reference distributions that are unique to your silicon and nobody else knows how to use, that demonstrate its features. But by gaining access to a wider ecosystem, in particular distributions, like Red Hat's Core OS, if you're trying to build an edge server, allow different products to be constructed from on top of your own effort. Similarly, once you have open embedded layers, then additional players can come in and build on top of the foundations that you provide. If you are a large-scale SOC vendor, the other thing you get from this is you've now got a very easy, comfortable route to refer customers with niche requests, because you can send them to contracting companies that have invested in your ecosystem. I'm including Lenovo, obviously, in our developer services division. And then finally, you also have a direct system for your own customers to contribute features and bug fix that benefit your silicon. And that's simply because the customers fully understand how to contribute upstream. Not all customers, obviously, but upstream is a well understandable place. You can get many excellent trainings on how to interact with the upstream, and your customers are able to take those trainings as well, and they can use the same processes to contribute additional features for your stack. So those can help drive down your costs. Additionally, we get things like increased quality and generality. So upstreams like Linux do have industry-leading quality standards, possibly none more so than Linux, where the quality threshold is as high as you will ever find in code written in C. Additionally, once you've upstreamed code, then as the Linux kernel develops, as new APIs are developed that make it more robust, effectively, the upstream code will be updated automatically to match those API changes by the proponents of the change. And the proponents of the change are usually those best qualified to make those automatic changes. The final reason why you might upstream is because somebody is requiring you to do so. It is reaching the stage now where certain highly influential customers and middleware providers may simply start to demand upstream drivers be available. It's not always the case, but those influential customers are ultimately leading you in the first two areas against your will, if you like. They're forcing you to figure out how to reduce costs and increase quality and generality. That's why they want it as well, particularly the generality and that capacity to have niche requests, chase contacting companies. It allows your own customers to be in charge of their own destiny rather than tied to you, which frees you to go and build your next product. So it's not a bad thing at all. The final bit of philosophy that I want to introduce in this first section of what upstreaming is to introduce you to a similar concept called working in the upstream. So working in the upstream is when the upstream kernel is no longer the thing that you move downstream code into. It's when it can become the primary focus of your development, where the upstream Linux kernel is where you can land features first prior to backporting. So if you want to support LTS kernels for particular customers, you can actually do it by backporting to them. And the reason people might wish to work in the upstream is once you can work in the upstream, you are now participating in leading Linux kernel development, ensuring that it develops the features that you need rather than following it. As a concrete example, I3C, which is coming along as an interchip communication to replace I2C, currently, last time I looked at it, had a fairly kind of rudimentary basic infrastructure. And SOC vendors were asking me, does it support this? Does it support this? Does it support this? And the advice was to get in a position where you can be working in the upstream. You can then influence the features of I3C to give you the features that you need rather than having to develop a proprietary set of extensions to I3C that will eventually get steamrolled by the upstream development when somebody else does it for you. So where you're working, particularly in places where there isn't a strong leadership at the moment and you care about it, working in the upstream is the way to get the kernel to become what you need it to be. For embedded platforms, that does have a caveat, which is that in order to work in the upstream, there has to have been sufficient upstreaming already taken place on your platform that your developers can meaningfully contribute. So for embedded platforms, the SOC vendor does have to invest in upstreaming first to make working in the upstream possible. And that's the last we're going to say today about working in the upstream. And the reason for that is the tools, techniques, and habits that are necessary to work in the upstream are very, very similar to actual upstreaming. What I will say is that example of those minutes that were posted was from a company that works in the upstream. And the very fact that they're having to build consensus for very, very cutting edge new features is a consequence of working in the upstream. But other than that, the habits and techniques you're going to require are going to be very similar. So there's a very natural progression that you can be doing upstreaming, and when you get to the point that your platforms are likely to work early on in their development life cycle, you can then look further at trying to work in the upstream. So the next thing before we get into the nitty-gritty of how to actually do some of the mechanical typing aspects of upstreaming, we'll have a quick talk about how the Linux project itself is organized. So the Linux project does have a great deal of centralized infrastructure around this website and other ecosystem, kernel.org. So kernel.org, if you put it in your web browser, is simply a website with various bits of information, some hints on how to get to the source control systems, and a number of different releases listed here. In particular, we have highlighted the mainline. Now, the mainline, as shown here, is the most recently released kernel by Linus Torvalds. Whether that kernel is a stable kernel or a release candidate, it is the mainline of Linux, is the most recent kernel published by Linus Torvalds. That is what anybody involved in upstreaming considers to be the mainline. If you have internal corporate branches that you call the mainline, that's fine. But as soon as you are talking to anybody outside the scope of your company, the mainline kernel will mean the Linus Torvalds kernel. And we know it's called mainline because that's what it says on kernel.org. Additionally, on that same page are a number of other bits of information that can be used to help you take advantage of the kernel development cycle in your work. So it will keep you aware of patches to the most recent stable kernel. It will keep you aware of all the long-term stable kernels and the patch levels they have achieved. It will also introduce Linux.next to you. Linux-next, sorry, is a pre-release kernel that takes all the Git branches that maintainers have made available for others to use, giving them hints about what those maintainers are going to give to Linus Torvalds in the next merge window, and pre-merges all together. I think it's about 250, 300 Git trees that are merged together to produce Linux Next and provide this pre-release kernel that is useful to test against. And then finally, there is an atom feed, which I've summarized on the right. So all the information that appears here is also pushed out as an atom feed, so that if you are maintaining a particular long-term kernel derivative, this can be a good way to keep on top of when releases are made and make sure you realign with the base and pick up the bug fixes. Who contributes to mainline? Well, currently, all the logos you see in front of you, these are not organized by amount of code upstreamed. They're roughly structured, so you've got ARM in the top left and Intel in the bottom right, and distributors and cloud vendors kind of occupying the middle space, but it's all quite approximate. But these were the top 16 corporate contributors to the 5.15 kernel. They will change. So some companies will come in and out, depending on when they've got big releases coming and what changes they need to make for their products. But that's a good snapshot of ecosystem, and I maintain a couple of logos off the side. So my master copy of this slide has about 22, 23 different logos. Some of them are off screen at the moment, so that I can bring them on when I move to the 6.1 kernel, whatever I choose next. I can bring in the other logos of people who pop in and out. So in terms of Linux organization, we have this practical coordination point, kernel.org. We also have the primary Linux mailing list, the Linux kernel mailing list, which you can join here if you're interested, or look at the archives here. Now, we'll discuss in more detail next week how to wrangle the mailing list, because the Linux kernel mailing list is one of the highest trafficked mailing lists in the world. And we need some tools and techniques to absorb the right bits of information from it. But for now, just be aware, there is a mailing list that all kernel patches are expected to travel through. And there are many, many other mailing lists for specific subsystems. So most subsystems have a mailing list associated with them that you can subscribe to get a lower volume. There's also an ARM-related discussion mailing list, which you can find here. Again, that was also quite high volume, so you might have to try filtering it. But with all that communication, all those facilities, all the infrastructure, there is a very strong organizing force to cover the whole of the Linux kernel. And that is Linus Torvalds. We've talked about, the mainline kernel is the kernel released by Linus Torvalds. And to that extent, what Linux is exclusively defined by what code Linus accepts into his tree. However, Linux got far too big for one person quite a long time ago. There are far too many different architectures, subsystem patches, sorry. One person could not possibly handle it. So Linus has around himself a very large number of maintainers who accept code from particular contributors, push them into Git trees, test them, push them, and ask Linus to take that code into the Linus Torvalds tree. To put this into perspective, there are, as of 5.18, last time I ran this code, there were over 1,600 Linux maintainers in various corners. Because there are a large number of subsystems to be maintained. And this splits down into subsystem maintainers, driver maintainers, file systems, architectures. Platform maintainers is an interesting one, particularly in the ARM and embedded space. It's very common to have a Raspberry Pi maintainer and a this maintainer. And so not necessarily looking after specific drivers, but looking after a kind of horizontal view of a particular SOC and how you make it run on a particular on Linux. But to be clear, this list of maintainers is not a list of maintainerships, is a list of maintainers, and several maintainers wear multiple hats and look after multiple components within the kernel. So it's not merely that there are 1600 unique maintainers, but some of them serve multiple roles within the kernel. It's inevitable, therefore, that if you create a large change, you might well be working with multiple maintainers to try and land code. So the rough structure, you end up with something of a hierarchy of maintainers. It is a fairly flat hierarchy. There are lots and lots of people who can send pull requests directly to Linus. But there are also driver maintainers who maintain software far more complicated than, say, I do. So at the top level, we have things like subsystem maintainers, which are things you find in drivers, basically pin control, regulator, I2C, USB, GPIO, lots and lots of different directories that you will find inside drivers. You have architecture maintainers who you find inside the /arch directory, so ARM, PowerPC, and so on. And we have maybe feature maintainers. So these are things that are significant software elements to them. So networking, although you have Ethernet drivers at the lowest level, networking is much more than just how to put a frame out on a piece of hardware. There's the full TCP/IP stack sitting in software, driving those hardware components, device tree, block device, file systems, all these things sit as kind of features. And in all these spaces, we've only illustrated it for the subsystem, but in all these spaces, there may well be sub-maintainers. You know, there is a VFS feature maintainer and the file systems sit underneath that. Here we might have, say, the USB subsystem, and the DWC3 is a tremendously influential, the Designware USB version 3 controller is a tremendously influential embedded USB controller that is stamped out in a very large array of hardware. And it has a complex driver with lots and lots of components and moving pieces. And that driver has its own maintainer who will then send a pull request to Greg, who is the USB maintainer, who will send a pull request to Linus. So maintainers do form hierarchies. As a contributor, you don't really need to worry about how the maintainers are organized into hierarchies because you send out emails and they pick them up. So it's not something you have to particularly care about, but it is useful to know that some maintainers will be sending pull requests to subsystem maintainers or architecture maintainers, and others will go directly to Linus. Maintainers are responsible for a number of things. They are expected to ensure that coding style is followed, that there is consistency, that the code is of high quality, that there was consensus when the patch was discussed. If there was a significant argument, the maintainer will be tracking that argument is happening and probably reluctant to pull until the consensus is resolved or achieved. And obviously that it's technically relevant and makes sense. So going with that responsibility that maintainers have, from the point of view of somebody who simply wants to contribute to the Linux kernel, doesn't at this point have aspirations to become a maintainer, maintainers are the only path to get code into the kernel. And in this sense, you should view the maintainer as a gatekeeper. It is their role to keep poor quality contributions out of the kernel. It is also their role, if you get a high quality contribution that needs changes, to insist those changes be made before it is applied. So even if you submit a very high quality patch that has a few missing pieces, it's still the maintainer's job to say no until those missing pieces are added. The only way to get your code upstream is to get a maintainer to apply it. I have said a maintainer here rather than the maintainer, and that is deliberate. Ordinarily, you would expect to have to get the maintainer for that area of the code to apply it. There are a few exceptions, like when code is not maintained or a maintainer is no longer responding. When there are 1600 maintainers, some of them do occasionally take very long breaks. There are a few ways to route round unresponsive maintainers, but in general, the only way you're going to get code applied is to get a maintainer to apply it. So that has some obvious consequences. If they ask you to change something, your first instinct should be to do what they've asked. If you think they are wrong, you have the capacity to discuss and argue. They're on a public mailing list. They have to engage in discussion in a meaningful manner, just as you do. However, if there was not a misunderstanding, if they understand the technical situation and are asking you to make changes, you will have to rewrite the change or the code will not be accepted. It's a process of technical and social influencing to say that the kernel will be better with your contribution than if the maintainer ignores your contribution. And if there are things that they think need to be changed, that means they will not take the patch. This is something you have to accept and ideally embrace. It's actually quite exciting. Working with people who have such high quality thresholds is actually a very exciting and interesting thing to be doing. So if you enjoy the technical mechanisms and everything else behind it, it's a pleasant experience once you've got over that shock. So if you need to land a feature upstream, if your job is to upstream such and such a driver, you have to accept that maintainers are the only path. Check your ego at the door and work with others to get the code into a state that it can be accepted by maintainers. Usually, this also improves your code. The final detail in all this is your schedule is of absolutely no meaning. So if you've told your manager you're going to land this change by kernel 7.2, there is absolutely no point in trying to use that to lever somebody to accept your code when it's not quite good enough. It won't work. Your schedule will have is of no relevance, largely because kernel maintainers know that there's going to be another kernel long in 10 weeks' time anyway. So they're very happy to wait and put it in the next kernel. So that's how the Linux project is organized. And for the next hour and a half or so, we're going to be looking at specific details of phases in patch creation. So first off, before we actually start to generate patches, we'll do some preparative work. We're then going through the kind of mechanical process of creating a patch, how to post it to the mailing lists, what feedback you can expect to get, and how you do what you should be doing after the patch eventually lands upstream if you're successful. So preparation, in a lot of areas, preparation is key to success. And this isn't actually very different. So there's two possibilities. One is that your manager has briefed you to write some new code and land it upstream. The other possibility, probably more likely, is you have some existing downstream vendor code and your manager has asked you to upstream that downstream vendor code that may not even have been written by you. And in both cases, the same type of preparation is worthwhile. The first thing is to figure out where the feature should fit in the kernel tree. This is perhaps much more obvious now in 2022 than it would have been, say, 5 years ago, because it will almost always live in drivers somewhere. Further back than that, there were a large number of drivers in Arch ARM for kind of historical reasons. And at that point, you could look at the code, look in Arch ARM, find a similar driver, and that would not be the example to copy because there's been this trajectory away from putting drivers in the Arch directories to putting drivers in the drivers directory and making them more generic, making them work with multiple architectures. So first job is to find the appropriate subsystem. If it's a watchdog driver, find the watchdog subsystem. If it's a GPU, find the DRM subsystem. So you find the appropriate subsystem, the appropriate part of the kernel where this type of driver is generally occupied. If your piece of hardware is just some weird bit of SOC specific glue, then you might find a home in somewhere like driver SOC. If it is entirely new, you might be looking at certain other possibilities. It's, you know, if you can have absolutely no idea where it should fit, it's a very good idea to go and find a mentor of some sort who can provide that kind of advice for you, whether that's senior kernel engineers at your own company or trying to reach out beyond the scope, beyond the perimeter of your company. So now, once we've found the directory, we want to look for similar code in the latest kernel so that's as similar as possible to what we're trying to work on. And I suggest that, well, perhaps 3 types of drivers you should be looking for. The first is a well-maintained existing driver. In a lot of subsystems, there are drivers that are very, very dominant and heavily maintained, probably because they're either very, very popular, like the DWC3 that I mentioned before, or because they exist in the x86 PC architecture as the main thing. So something like a 8250 UART and the 16,000 UARTs that are derived from it. Those are examples of drivers that are used pervasively, and they get very heavily maintained. Even in smaller subsystems like backlight, the PWM backlight is much more heavily maintained than single backlights that use some obscure part and are only present in like 3 mobile phones from 5 years ago. So look for one that's well maintained. That's the one that will be used as a reference driver by perhaps some of the maintainers within that subsystem. Also look for recently added drivers. So the reason you're looking for recently added drivers is because maintainers themselves develop skills over time. And code that a maintainer may have happily accepted 3 years ago may no longer be acceptable today, as that maintainer has learned more about maintainability or the technical domain that they're maintaining. So it's not good enough to be the same as some other driver. You want to look at the recently added drivers that use all the latest APIs, are written to all the latest standards, and have applied all the lessons the maintainer has learned over the time they've been maintaining. That's the driver that most likely has the best code style to be copied. The final driver you want to look for is one whose hardware data flow is most similar to the hardware you're working with. So if you have a piece of hardware that uses MMIO to read from a FIFO, and the driver that you are using as a template or to learn from uses very, very complex DMA-based data flows, the impedance match will be too much. You won't be able to see enough of how the driver works by reviewing that. So that gives you, 3 drivers maybe to have a decent look at and figure out which aspects of those drivers you would expect to see in the driver you've been asked to upstream. And you can then take lessons from that and apply it to the code that you need to upstream yourself. I don't want to give you the impression this is like a 2-week research project. You should be able to find those 3 drivers and get the gist of how they work in less than a day. It's not a big project, but it's a worthy bit of preparation to understand the type of code the maintainer is going to accept. The final thing that's worth doing in this preparative stage is to read the archives of mailing lists and look for other people who are upstreaming drivers to this subsystem. Look at the email history of the recently added driver. Find out if there were many changes the maintainer recommended making. If there are, don't make the same mistakes that somebody else has already made. Find a new and interesting mistake and make that instead. In all seriousness, the information of what the maintainer wants to see is all recorded in those mail lists. So watching those mail lists, particularly just looking at the last 2 or 3 driver contributions and seeing the mistakes that they made and reviewing the code you've been given from the vendor tree and see if it makes the same mistakes. Because if so, you might as well clean them up before you start upstreaming. This is what the preparation is all about. It's putting you in the best place. When you upstream a vendor driver, one that's been written by somebody else, you're actually doing the first code review, is the best way to think about it. So you're doing a very aggressive code review, trying to meet upstream standards and trying to second guess what review feedback you're going to get, and then acting on your own review before you upstream. So what can help you with this? First off, there's document, as well as the looking at existing code, there is the documentation directory. The documentation directory has lots of general advice on how to submit patches and things like that. It also has specific information about how to write certain types of drivers, how to use DMA effectively, how to use clock APIs. So where there are APIs you need to use, you can read the documentation about how those APIs work. We also have to think quite a lot about device tree bindings in the ARM world. So there are 2 popular hardware descriptions in ARM ecosystem. One is device tree, and the other is ACPI. If you're writing for ACPI, there simply isn't the same depth of documentation to follow because there are the ACPI standards that you can read instead. But for device tree, we have the device tree bindings documentation, which is maintained in the Linux kernel, and is a tremendously important source of documentation about how to interface with hardware and to describe hardware. So look for similar bindings for similar pieces of hardware. Look at existing users of those bindings in Arch ARM and ARM64 boot DTS to see how they get used in the real world. And then finally, excuse me, finally, there's also the device tree mailing list itself. So you can look at some of the information about device tree. It's coming up in a few slides' time. But you could also spend a couple of weeks subscribed to the device tree mailing list and find out what bit of feedback the device tree maintainers give over and over again. I strongly suspect that Rob has said dual license to quite a lot of developers before Robert. And there will be other common bits of information that the maintainers give out. So learn from it. Make yourself more efficient by getting a sense of what these things are. I wouldn't necessarily stay on the device tree mailing list, but having a look at some of the recent history or just joining it and letting it flow through your email box for a little while can be a good form of self-education. It will help you spot patches going through that you can learn from. Just by having them pass your desk, you think, oh, that's related to what I want to do, and have a look at it and see how they've done it. So to explain, last thing about preparation, the kernel structure and the kernel API are constantly changing. There's a famous document within the documentation directory called stable ABI nonsense, which explains why they are constantly changing and why that is regarded as a good thing. So even when you find code in the latest Upstream kernel, it might be shortly about to be replaced. There might be changes coming through, particularly if you have a vendor driver. There may well have been changes since it was written to provide new and better APIs to adopt. That's one of the reasons we've been doing that preparation in the first place. However, you can't be a mind reader. There is at some point you eventually will send these things out and you'll get a review that tells you about the new APIs. So again, one of the things I like to do on the mailing list is just lurk and read for the you need to use this API, because it introduces you to useful tools in the kernel that you didn't know about. So yeah, and the final part of preparation is as soon as your manager has said to you, I want you to work on this driver, you should probably go into the maintainers file at the top level of the kernel and find the mailing lists related to the subject you've been asked to work on. And again, subscribe to that mailing list, just let it flow through your email box. You don't have to read everything, but it will just give you some hints about how that subsystem operates. You'll get to watch how the maintainer works and how you can then see, I guess, what type of technical and social influencing is most effective with the maintainer that you have to work with for the time being. So that's why we look at these mailing lists, to see how the social aspects are being organized for that particular subsystem, because they're not all the same. Right? 1,600 people do not all have the same preferences on how you communicate, how you deliver code, etc., etc. So there is a lot of commonality, which is what this course is all about, but there is also individuality, and that's one of the reasons it's worth joining a mailing list to watch. If you're really stuck on which mailing list to join, you could join the ARM kernel mailing list. I'm not sure I would recommend that because it's quite high traffic. And then finally, if you want to see some kind of real-time chat on what ARM Linux developers are doing, this is a kind of lubricant that sits behind the mailing list, Internet Relay Chat. You could look at ARM Linux on LiberaChat. So that's patch preparation. We're now going to step into a second related topic, patch creation. So between this patch preparation and patch creation, there's an implicit assumption that you've now written the C code. Yeah, there are lots of this course isn't about how to technically write good quality C code or to write good quality kernel code. We do have other courses on that, but the assumption here is that between patch preparation and patch creation, you've got C that you are now happy with. You've got a make file that you're happy with. You've got kconfig set up as you think it should be. We're now trying to translate that change that you've proposed into something ready to put on the mailing list. So first things that are worth looking at this point, now we've got everything, are these bits of documentation. So the first two are an overall process for submitting patches, gives you various bits of advice. And there's also a thing called a submit checklist, which you can use as a kind of reminder, particularly when you're starting out, to make sure that you've covered all the bases that you're expected to cover. If you are device tree specific, so if you're making changes that impact device tree bindings in particular, or any other device tree device tree changes, then looking at the device tree bindings documentation is an excellent idea. So just to give you a sense of what these are, incidentally, these are restructured text files that can be generated into HTML. So I've given you links to the comfortable HTML versions. There's also other things in here that we haven't kind of linked to, but there's lots of other documents involved in here that you can find lots and lots of interesting things about kernel development by just browsing the documentation. So it's what it's for. The device tree documentation is much more compact. This is just like one page of do's and don'ts for the best way to design device tree bindings. These are effectively a list of the boring mistakes that you can make. Make interesting mistakes. So these are some advices on how to write the best device tree components you can. And then there's a thing about how to organize patch sets when you send them through, this submitting patches idea. So all of those documents I would strongly suggest that you read before you first send your initial patch. And then after you start to get the hang of things, maybe reread submitting patches after you've started, to make sure that you're not developing any bad habits. Patch creation, testing. Testing is an important part of patch creation. It is expected by Linux kernel maintainers that you have done at absolute minimum compile testing, and runtime testing will be assumed if you haven't explicitly said you didn't do any. So yeah, they expect, and they expect two properties to be maintained. One is that they do what they say they should do, meaning that they are assumed to work on your hardware and do something useful. The other is they don't break anything else. So they don't spoil the build, they don't damage the build, they don't break the build if you turn it on for anybody else's components. Now, the Linux kernel is hugely configurable, 10,000 or more configuration values, if I remember rightly. You can't possibly exhaustively test everything in that space. Good starting points, if you're working on 32-bit ARM, is multi-v7 def config. If you're working on 64-bit ARM, then the def config, there's a single def config that is recommended. Excuse me. That's a good start. So you can build it without your device kconfig set. You can build it with your device config set. You can build it set for modules. And if you've got multiple config options, you can explore the config space and make sure they're all compilable. If you're making a new driver or a heavily modified one, then using all mod config can be very useful. That basically makes the kernel as modular as possible by pushing everything out to a module that can. And it's really good for compile testing, because the final stage is a link compatibility stage that looks at all the modules and makes sure the symbols actually work. They've been exported. They can be shared as they should. So def config and all mod config is an absolute minimum kind of level of testing that you should be applying to your changes. There is a possibility that you can't test on the mainline kernel because you haven't upstreamed enough other dependent support yet. So it may be the case that you rely on other patches, in which case you can test with those patches applied and put in your covering letter that you required this to do the testing, and advise on whether or not your change can be delivered independently. So if, for example, all you require is the clock subsystem to be added, but your driver is independent of those changes, in the sense the system will be compilable but not work at runtime, that's acceptable. You can say it's okay to take this patch set. But where there are compile time dependencies between patch sets, you definitely have to call them out. to make sure that nobody takes them out of order and creates an uncompilable tree. The other aspect of, so I'm just going to change these around because I formed the conclusion this morning that they're not in the most helpful order. So I'll pop them down like that. The other aspect of creation that takes quite a long time to get the hang of is correct splitting up patches, splitting them out into the smallest possible change that you can make. And the rationale for this is that a patch series is kind of like telling a story for the maintainer to understand why you've done what you've done and what you've done. And each patch is a chapter in that story, and the smaller and simpler the chapter, the easier it is to understand the story as a whole. So we want to split the work up so that each piece is atomically separable, if you like. And once you have written the C code and you're starting to create patches, the other thing is that the patches should be ordered in the best way to tell the story. They should not be ordered in the time order that you wrote the patches in. Because nobody is going to sit down and make all the changes in true temporal order, commit, and get it right first time. They're going to have to shuffle things around. They're going to move things around. We'll briefly discuss some of the tools involved in that next week. And the reason to do that is it makes the patches easier to read. And by making patches easier to read, they are easier to review. And that means they're less likely to be ignored. And I've put ignored in quotes here because it's not the case that maintainers, or not very many maintainers, will sit there going, oh, that's a really complex patch, I'm just going to ignore this person. It's much more likely they say, oh, that's a really complex patch, it's going to take me ages to review, I'm going to defer it and work on something else until I've got time to look at this tremendously complicated patch. And that might keep happening. So they're not, strictly speaking, ignoring the patch, they're just prioritizing other work because the review is too difficult. And that's rational and correct and good for the Linux kernel. So by adopting smaller patches, by making your code as reviewable as possible, you are increasing the likelihood that the maintainer is going to pay attention to the patches you share. So we have an example story here where we've made some changes to the OMAP to I2C controller. This is hypothetical. It's not a real patch set that I've copied. This is a hypothetical story. So the first thing we did is we found a hard bug. We're saying fix a bug when the probe fails. Bug is a macro that causes the current code to crash. So we fix a bug that occurs if the probe fails. Now that is a mistake in the code, and that's the sort of change that might want to be backported to previous kernels, which is why we've popped it first, so that it can be easily separated and backported to stable kernels if needs be. We then got some tidy ups. We have clean some cruft. Now this is a terrible, terrible name for a patch. If we weren't doing example, we'd expect this to be a much more descriptive thing. You can compare this to other things. You've got fix a bug and update to use new I2C APIs. Those are nice, clean, concise summaries. Clean cruft isn't. That probably should be much more descriptive. But you can see how we've separated these things out. The bug fix is separated from this little tidy up. The tidy up is separated from an adoption of new APIs. Because if you can tidy up and then adopt APIs, that's much more smaller. We can now look at the things that are small tidy ups, and we can see the things that use new I2C APIs, and we don't have to figure out ourselves which ones are which. Really does simplify the review process. It makes it quicker. It means that you can send maybe a reviewed by on a couple of things and ask for specific changes somewhere else. Small patches are much, much easier for reviewers to work with, and they are a very effective way to upstream. The exception to that is new C files. There is no need to introduce a new C file in pieces. So if you have a new driver, it's perfectly acceptable to drop the whole driver into a single patch. So the reason we split up the patches is to make it more reviewable, and the split point is to do with the reason and the function of the change. The other thing we might be doing is splitting it up so that things that are maintained by one maintainer go into one patch and things that are maintained by a different maintainer go into a different patch. Again, that makes it much, much easier for maintainers to review if you can separate the changes based on the maintainerships. So we can split up the patches according to that reasoning function. It's okay to change multiple files at once. It's not that splitting a patch does not mean a file at once. It means a concept at once, and it means that it's not the case that you have to make a change on this file and then this file and this file. That's actually often not helpful because it spreads what you're trying to do across multiple patches. So it's not file based, but it is subsystem based and it is concept based. The other thing can happen, however, after you've split your patches up is you may have intermediate levels of patching where the tree is not compilable, and maintainers really don't like that. So every patch that you ship is expected to leave the tree in a buildable, compilable condition. That property is called bisectability, which is named after the git bisect tool, which is an automatic regression finding tool to search for regressions between a known good and a known bad set of patches, and it basically does a binary search through. And binary searches in the presence of code that cannot be compiled degrade very quickly in their quality, and you can still search, but it takes much longer and it makes everybody miserable. So maintainers do seek to keep bisect working as well as they can, because it's a key point of making the kernel more maintainable. People will make mistakes, bugs will be added. Being able to bisect and find out where the bug was added, and particularly when it's a small patch and doesn't carry a lot of baggage from lots of other components and other changes, that not only makes the kernel maintainable, when the fault is found, it's usually a small one that can be easily understood. So yeah, all that really means is be very careful to make sure that when you introduce new features, you add all the pieces that you need. You add all of the C files, you declare all the variables that you need. You don't declare a variable in a later patch that you use in a previous patch. Obviously, testing is the way you can find out if you've achieved this or not. So we've now got our patches nicely split up, and we need to make sure that we describe them well. So what we will see is different subject lines in the emails going back and forth. We saw this in the various patches we had looking at the beginning. So let me find this one. Photo review notes. So you can see we had our various subject lines describing the subsystems that we were seeking to modify, or Robert was seeking to modify, and a description of what the patch is going to be, and in this case patch v4 and the full set. So there are a couple of different habits you see. For multi-patch series, like the one we were demonstrating, you do have a part of the subject line that describes where we sit within the patch thing. So this is patch 1 of 11. It means people know there are other patches that are involved in the patch series. Patch 0 is special, that's the covering letter. So patch 0 is technically optional, but most patch series should contain a covering letter, which will be described as patch 0. And then you have the functional patches following through. You can have single patch submissions. So where you have a single change unrelated to anything else, this is very common for bug fixes. You don't need to put it in patch series. In this case, we are showing the version number. So there's also this incrementing version number. So without a version number, there is an implicit version number of 1. So when there's no version number present in the patch, it's assumed to be version 1. And then if you ship a second version, you'd be expected to add a tag to show that it's version 2, version 3, version 4. We then have a final tag, which is quite interesting, the request for comments tag. This does not mean I've got a junk driver, please tell me what's wrong with it, because if you do that, you will get a lot of nitpicky replies and not much actual useful information about the strategy. If you submit a clean RFC, where the code itself is relatively easy to read, you can ask questions about architectural matters and get hopefully helpful responses. So a request for comment is usually done to request technical guidance, to say there's 2 ways I could implement this, which is the right one, and hope that somebody else can give you advice on which one would fit better into the Linux kernel. So where you're not sure of technical direction, an RFC is an excellent way to learn about it. But you do have to be very careful that what you don't get back is a whole bunch of comments about bad coding style, because that just distracts from the technical question you're asking in the first place. So yes, it does not mean that you can throw half-complete drivers at things and hope somebody else does all your debugging for you. They won't be willing to read it at that level. But it can be a good way to express a technical question if you want to ask one. And then, is it finally? Not quite finally, no. Then we'll talk about commit logs. So a commit log is your chance to sell your patch. Upstreaming is a process of technical and social influencing. So the commit log is where you really have a chance to influence somebody to say, yeah, that patch will make the kernel better. I need that patch. I don't want to ignore it. So it's your chance to say why the patch is needed, what the patch implements, and how it does it. A good example is in this sentence here. So the conditional in function X did not handle the case Y, and that caused this platform to break. Add an additional conditional and an error path so that we can handle Y correctly. That is saying why the patch is important. It's broken on certain platforms. If we add this, it will work again. That is a tremendous, even in those two sentences, amount of information for the reviewer to check that they agree that platform Z is broken, to check they agree that the reason it's broken is because conditional X is not working. And then they can check to make sure that the code is correctly doing what it's advertised in the commit log. So every commit is expected to have a useful and complete commit log. Comprehensive does not necessarily mean long, but it may well mean that it describes everything the patch does, and the length that you need to do that will depend on the nature of the bug or the feature that you're adding or whatever else. Do be aware that reviewers and maintainers will complain if there are changes in your patch that cannot be predicted from the commit log. So if you add an extra small tidy up at the bottom, a spelling error, you'll still get asked to put that in a separate patch because it's unrelated to the change you're making. So if you find that what the changes you've made when you read back through a patch are not described in the commit log, that's usually a sign you should have split up differently. And finally, although this might seem like a lot of fuss, this kind of rigor is not merely for the benefit of the maintainer. It's going to help people who in the future need to understand why this change has been made for bug fixing or further trouble or anything else. And given that the change is being made is something you care about, there's a very good chance that that future adventurer is you after you've forgotten how your change worked. So it will pay dividends to somebody. Maybe it will pay dividends to you. And certainly when you have to chase bugs in the kernel and other people have written good commit logs, it makes your life so much better, so much easier. So it is expected and it benefits other people and you potentially. So look at the existing Git logs to get an idea of the sort of commit logs you see in the kernel. That's what you are aspiring to. So that commit log should be saying why the patch is needed. The commit log should be saying what the patch does and why. It maybe should also say what the patch does not do. If you've deliberately decided not to do something, you don't think the feature is necessary, or you're planning to handle that bit later, or the hardware is broken and it's known to be broken, so there's no point in enabling this feature, say what you haven't done as well. Because otherwise reviewers will be saying, add this, add this, add this, and you'll have to say, no, no, no. So if there are things that your patch deliberately omits, say that they're deliberately omitted and why. And then finally, if you've got something in your patch that is not in the patch description, either remove it, add it to another patch or anything else, or update the commit log. But the commit log should be about one subject. So if the commit log ends up about two subjects, that's an indication again that it should be two patches. During the initial creation process, you must include a signed off by tag. So next week, we will describe exactly what a signed off by tag means, what you are signing off. But it's essentially saying that you have the authority of the copyright holder, which may or may not be you, to release code licensed under the GNU GPL or another appropriate license and have it added to the kernel. It's a legal statement. Like I say, we'll be discussing exactly what it means next week. But when you add a signed off by to a Git commit, that is what you are signing. You are signing this certificate of origin. There are other tags as well that you might be adding during creation process. You might be adding reviewed by if you've had some internal in-house review before you release. You might be adding tested bys if other people have tested it. You won't be adding an act by during creation, but act bys may come up during review. And in the second and third releases of your patch set, you might be adding act bys into your patches as well. So these just get put in the commit information. So excuse me. So you can see here that, where was it? Sorry, I've opened too many of these now. I can't find the one I wanted. Go back to here. I'll stick to this one. So here we have the signed off by. It's just part of the commit message. It's nothing special. It's just a particular format of text that appears inside the commit message. And I know there are other patches in this set that have a reviewed by Dmitry Barashkov as well, which indicate that the patch has previously been reviewed by a particular person. Unfortunately, I'm not going to sit there stabbing at buttons to try and find it because it's distracting for you and a waste of time. We will also go into exactly what all these tags mean next week when we're looking at tools and techniques. So an aside, but I think quite an important aside, it has got your name on it. The Linux kernel technically does not accept anonymous or pseudonymous contributions, although if you have a normal looking name, few people are going to challenge it if you present it. But yes, when you upstream, particularly in a corporate setting, it has your name on it. Your name is then associated with that piece of work. So I think you would probably prefer your name to be associated with high quality patches. That's what everybody's going to aspire to. And you certainly don't want your name to be linked in the community with poor quality patches. Because if that starts to happen, if you have a long history of submitting poor quality patches, your upstreaming work will become more difficult because people will start deprioritizing reviewing your work because they don't expect it to be of high quality. And they know it's going to cost them more time to review. So you want your name to be associated with high quality work by doing the very best you can. There are other direct reasons that you want this to happen. I mean, emails and patches are archived in mailing list archives. They will sit there in search engines and can be found years and years and years into the future. More than that, mails about the kernel also rank quite highly on search engines because it contains a lot of highly linked to websites. So there's a good shot that if somebody puts your name and patch into a web search, they will find some of your contributions to the Linux kernel. And you don't get to choose what order the search engine puts them in. So for every contribution you make to the kernel, that could be the first thing that pops up when if it's legal in your jurisdiction, a future employer does some due diligence. You don't get to choose what's going to pop up, so you have to make sure everything you do is professional and you can stand behind. And yeah, I've done this search on myself just out of curiosity, and it was a little while since I last did it, but the patch it picked up as my most important contribution to the Linux kernel was from 2015. It was some throwaway patch for a small bug that I had completely forgotten ever having experienced. And as far as I remember, there was some discussion after that and an alternative proposal was adopted. So I catalyzed change, but it wasn't my patch that eventually landed. And I'm happy with that. I'm quite happy to catalyze change. That's what upstreaming is all about. I've done my technical and social influencing, even if somebody else wrote the patch. But that's what I think was ranking highest the last time I looked. And it will change over time as things move on or particular buzzwords become important and as the search engines change their algorithm. You don't get to choose what will pop up in front of a potential future employer. So make sure everything you send, your name is associated with the best quality that you can. There is a thing here about ego checking. So be mindful of what you do. If you receive a review that creates a kind of emotional reaction, you feel the review, it's a good sign you should take a keyboard break. You do not reply in anger. Perhaps open a non-emailer, write what you want to say, in a non-emailer where you can't accidentally send it, because your muscle memory will automatically make you send emails when you finish and walk away. So open just a text browser, text editor, work on some replies, take a break, come back and read them, figure out if you are reacting with excessive emotion and anger. This is really easy for me to say in a training session, and you'll nod and say, yeah, I'll never do that. It's much, much harder in the moment. It's really easy in a classroom to believe that, oh yeah, I'll take a keyboard break. Why would I? Well, you know, I'm very relaxed. It will never happen to me. When you feel that knot, react to it. Take a break. Don't send something out without thinking it through properly. And then finally, it's not just your name. It will also have your employer's name on it as well. And poor work with your employer's name on it is a reputational risk to your employer. And more than that's an additional detail of having an employer in your email address. That means that maintainers know that you do this work for a living. You are paid to do it. You have got a job contributing to the Linux kernel. Maintainers expect professionals who are paid to contribute to the Linux kernel to know what they are doing. This is in quotes. It's a paraphrase from Greg Crow-Hartman. If you work for a company, you're paid for this. It's your job, and you'd better know how to do it. What that roughly translates to is some maintainers will spend a lot more time nurturing and mentoring hobbyist contributors than they will professionals who are being paid to do it. Because part of being paid to do it implies that you get to go on training, that you talk to people, that you have colleagues that you can use as mentors, and maintainers should not have to fill that role for you. So yeah, with an employer's name on it, you will get terse replies. People will have higher standards, and that's okay. But you do have to make sure you connect yourself inside your company to get that support the maintainers expect you to have. This is a possibility in the worst cases. So I won't read this out, but this was basically I've seen the question, I'll come to that in a second. This was basically a situation where a company was being successful upstreaming in the sense they were managing to land code in the kernel. The problem was that that code was causing problems and pain for maintainers after the fact. So this created a certain amount of crossness from Linus Torvalds, and the name was there. The name of the company that was having the trouble is very clearly listed, and it gets picked up by news organizations and all sorts of things. So I don't want to put this up to scare people. Upstreaming is a very pleasant activity, but just, you know, it's not just your name, there's your employer's name as well. You are representing them, and you mustn't ever forget that it's not just your name, that you're involved in these things. Okay, so there's a question about come up in the chat. So does the person who sends the patch upstream have to be the author of the patch? Absolutely not, no. There is no requirement for that to happen. It does depend on your relationship with the person who wrote it. So if you've picked up the work from somebody else, you may choose to ask them if they would like to sign it off as well. So you end up with 2 signed offs. But what you sign off, we'll discuss next week, is either that you wrote it or that you know it to have been GPL licensed, i.e. one of your colleagues wrote it at work and it therefore belongs to the company. So you don't have to preserve authorship, but you may choose to give internal credit and everything else. But yes, there is no requirement that the person who sends it upstream has to be the author. And yeah, we'll see this spelled out when we look at what the developer certificate of origin is next week, because that's what you're signing. When you sign something off to send it upstream, it's the developer's certificate of origin that you're signing. So we'll look at exactly what you're signing next week. Okay, while we're in this area, this is a couple of slides I'm not going to read out. These are key points of the submitting patches document that I've suggested you should read elsewhere, with particular pieces highlighted about things like how to write a good summary, how you have this patch tag summary phrase format for emails, and that there are tags like version 1, version 2, version 3, and RFC. So there's all the things that I've shown examples of before. I'm just connecting it to the documentation for you. For that reason, I'm not going to read this all out. These slides are here for you to study as you wish later. It's also in the reading material that I've linked to and suggest you look at. So this email on the screen right now has probably been the single most influential thing over my own upstreaming work. And it's great because it's really, really short and really, really succinct. So what we can see here, this is a patch that was submitted to modify something in the way the heartbeat works in the LED system, I believe. And it's saying panic, improve the panic timeout calculation. That's a good subject line. But inside the patch, it says we want to calculate blinks per second, and instead of making it 5 by this, let's make it 4 so the user can see 2 blinks per second. That is not a particularly good description of a patch, because you could probably read that from the diff stat, sorry, from the diff. You would see a 5 being removed and a 4 being added, and you might be able to figure out it's 2 blinks a second, you might not, but it doesn't tell you why. It doesn't tell you what the problem is. It doesn't tell you why the kernel is better with this change than without this change. It doesn't tell the maintainer why they shouldn't just ignore it. And the feedback they got was very succinct. Please use this customary changelog style. Currently, the code does this, and this is bad because something else. We can improve this by doing this, and this is why it works. That's paraphrasing. You can read the original phrasing as you wish, but basically, currently this happens. It's bad because of this. We're going to do this to fix it, and it is correct because of this. That's a really good set of things to cover. You don't have to do it in 2 sentences. You don't have to do it in that order, but that is covering all the bases that people expect a changelog to cover. So we can look at this, which is an example of a well-written commit message. It is still not long. It is still very short. It doesn't cover the bases in the example from Ingo on the previous slide, but it does cover all. It doesn't come in the same order, but it does cover all the bases. So here we say that on this board, there are 8-bit SD controllers. And so we're going to pass an appropriate bus width property to reflect the 8-bit wide. And if we don't do that, they will operate with a default bus width and essentially run at half speed. That is basically saying that currently this code is absent and they run at a bus width of 4. It is implicit that 8-bit is better than 4-bit, but I think most people who understand communication, and certainly the SD maintainer, would know all this sort of stuff. So that's a good commit message. It's not exactly this format. It's not saying currently it's 4-bit and that's bad because we could be 8-bit. We can improve this by doing 8-bit and it works because it's 8-bit. You can see why you wouldn't phrase it from this template. But all the pieces of that template can be found in this reply as well. So that's an example of a good, well-structured commit message. And that's what I want to put in front of you just at this stage in the presentation, because we're about to have a brief break. So I call this the commercial break. It's a little bit tongue-in-cheek. The reason I call it the commercial break is that based on previous courses that I've delivered, when I said this at the end of the presentation, the important bit, which is how to gain access to post-support training, doesn't tend to land. People don't remember it. To the extent that I had feedback saying, I didn't know how to contact you. And I said, well, I did tell you at the end of every presentation. So we've moved it to the middle to try and improve retention. So here it is. First off, I mean, the training we deliver today is part of Lenaro's Developer Services division. So this is training that we sell on the open market as part of our professional services wing. We also provide it to members at no additional cost. So for club and core members, our training can actually be, we can deliver private deliveries, and for group members, we can deliver this training in this format as a webinar format. But this is something that we do charge some companies quite a lot of money to receive. So we have our catalogue online. As I said, club and core members, you might wish to peruse the catalogue and then discuss with your managers or training organisers whether you can receive those as part of your Lenaro membership. if you want to work beyond your Linaro membership or you're a group member, again, you can come in as a customer and purchase additional training if you need it. However, like I say, this is the full course. There is nothing we'll be talking about today that you have to pay for. There's no extra you can unlock by paying. This is the full course. I just want to be quite clear on that. This isn't a loss leader or a demonstration. This is the full upstreaming course. So you will be receiving everything that you would get from the upstreaming if you were purchasing it. So Linaro Developer Technical Support. This is another service that I manage at Linaro alongside training. And it's developer to developer support. It's not a support service. Can you reset my password? We have IT at linaro.org for that. This is developer to developer technical support, staffed by experienced developers and reinforced by the various domain experts we employ. So we can go and talk to the actual developers to gain help to give you an answer. And we stand behind everything Linaro does. Everything Linaro does, including this training. So if there is anything you want to ask about this training in the future, you give me a slide number and I will look up the slide, find out what I was talking about and help discuss or amplify the point that was being made. So yeah, we are here to help you. You can contact technical support for anything related to Linaro, including things that you have been trained on. To gain access to support, there's a couple of different routes. Support@linaro.org is the one I tend to recommend to people. You can do it in a web browser as well. Support.linaro.org will allow you to do it. And the last one is there because I think this lands better with people. If all you can remember is I need some support from Linaro, if you type Linaro support into a search engine, you should find a guidance page that will share the email address and the web browser with you in the top 2 or 3 results. Linaro is an uncommon word, so you will tend to get quite good quality hits if you search for that. Or if you want the really, really simple, too long I didn't remember all that, support@linaro.org if you have any questions related to the training you've received. Now, I think at this point, it's quite a... Oh, I haven't got it on this machine. Normally, I put up a 3-minute timer at this point because this is quite a fast-paced course. I'm quite a fast-paced presenter, and we're delivering remotely. It is slightly fatiguing to work in this environment. So I'm going to just take a 3-minute pause. So 25 past the hour, I will come back. I am going to go and fetch some more water at this point. I'm not going to introduce any more new material in the next 3 minutes, but if anybody puts any questions in the chat, I will be very happy to discuss questions when I get back after visiting the tab. So I hope you'll excuse me for a minute. I shall be back very, very shortly. So sorry about that. Like I say, it's nice to have a break, but to be honest, this is my second delivery of the day. My voice is definitely starting to feel the amount of talking I've been doing, and I do need to keep my water stocked up. And we are now 25 past the hour. So thank you for your patience. I shall move on to the next couple of sections. So patch posting. At this point, we've created the patches. We've got them stacked up in the Git version control system. We've got good quality commit messages. We now need to do the mechanical process of getting the patches out of Git and onto the mailing list so they can be reviewed. The primary tool for this is Git format patch. So Git format patch will take the patches and convert them into the patch series that we're familiar with, the patch 1 of 6 and so on. It has some command line options. So -- cover letter will cause it to generate a template to put the cover letter into. We can also have things like --2 and --cc, which allow us to say who we want to send the patches to, and we'll look at how we generate those addresses in a moment. But it's a cyclic process. You usually do Git format patch, you then do some checks, you push them through things like script check patch, you do some build testing, you run something like script get maintainer. And after that, you then know who you want to send it to, and you run it again with changed arguments and generate the final patch set to go out by email. So the other things I think you should do after you've done Git format patch, firstly, you should always ensure that you have run check patch on all the patches before you send them to the mailing list, ideally with -- strict. And that's simply because one of the things that frustrates maintainers more than anything else is receiving patches with style problems that check patch should have told you about. The other thing that maintainers really don't like is being sent code that doesn't compile. So after you've done the various bits of splitting up and modifying patches to divide your C into an appropriate patch set, build and test exactly what you're posting. So very few things can harm your reputation more quickly than sending uncompilable code multiple times. So the first time, second time, you can apologize, explain how it happened, and so show that you're going to change your habits and not make that mistake too often. But frequently sending uncompilable code is very much going to get you into a bad place with maintainers. And at that point, we've now got something ready to send out. We just need to know who to send it to. I've talked about 1,600 maintainers. How do we find who we send an email to from our 1,600 maintainers? And that's where this scripts get maintainer Perl script will parse the maintainers file and help you. So we'll come to that in a second. We'll go back to that. Once you've got your emails to send out, so you've done Git format patch, you've used --2 and --c on Git format patch to generate appropriate templates. You've filled in the covering letter. The final stage is to push it out to the mailing list. The very best tool to do that with is a tool called Git send email, which you pass the patches to, and it will construct, basically it will read out of those things, the 2s and the CCs and everything else, construct the emails, give it an appropriate thread ID and send it out. You do, of course, have to learn how to navigate your corporate firewall and email servers. I can't give you specific guidance on how to do that, except to say that in every company I've ever worked for or with, it's been kind of folk knowledge. Sometimes it's put on a wiki if you're really lucky, but you can certainly find experienced colleagues and ask how they've set it up, and they'll either help you find the correct wiki page or they'll show you how their processes work internally. The same thing goes with knowing how to send plain text emails. So when you discuss things on the mailing list, etiquette does dictate that you use plain text. You don't send HTML emails. And while you're working out to Git send email, it's a good idea to talk to colleagues to find out how they set up their emailers as well. There is advice in the Linux kernel. There's a documentation, email clients. But learning in-house how you navigate your own mail servers is the very best way to handle how to send the mail externally. So the last thing I think we had here in this how to send them out is working out who to send them to. And we do that by studying a file called maintainers. It's human readable. It's using tags, but they're fairly kind of obvious tags. M is maintainer. R, which isn't present here, would be reviewer. L is mailing list. W is website. S is status, in this case maintained. And F is file or file hierarchy. So this is basically saying that Russell King is a maintainer for everything found in /arch-arm. However, because of the use of tags and the canonical format, it is also machine parsable. So there's a script called script get maintainer that can look at the changes you've made, figure out what files you are changing, and from there, figure out which maintainer you should be sending it to. In concrete terms, I wrote and committed to Git a fake SD host controller driver called the host controller driver foo. So this is just some C code I committed for this example. And I can run scripts get maintainer pointing at a file called drivers mmc host foo.c. And what come back from the get maintainer script is firstly that Ulf Hansen is the maintainer for MMC, Secure Digital, and a few other things. So if you're sending a patch to add a SD host controller driver, it should be sent to Ulf. He is the maintainer. You'll notice it's picked up me as well. That's because it looked in the Git history of who's modified this file and figured out that I made all the changes, which isn't very helpful when you've created a new driver because you'll be the only author. But if it's a file that you're bug fixing, you will get a list of the contributors that modified the file. And that can be really helpful because they will be involved in reviews as well as the maintainer. So it's a very good idea to look, particularly when you're doing small changes, at who else has worked on the file and add them. And then finally, we get two additional lines. We get one indicating the mailing list. I'm actually going to bold this because it's kind of hidden. We get one integrating the subsystem mailing list. So this is a mailing list you should put on CC so that everybody who works in MC subsystem can see what's going on. And then finally, you should also copy the Linux kernel mailing list. All patches should be copied to the Linux kernel mailing list. So from this, you would add ULF to 2 and Linux MC and Linux kernel to -cc of your Git format patch. You can also point get maintainer at full patches. So here I've got my dummy driver for foo, and you can see it's given me a lot of additional output. The reason it has given me a lot of additional output is because I modified a make file and a kconfig file. And so what we're seeing in all these authored one line, authored one line, authored one line kind of thing here is other people who modified a make file. They're not people you particularly want to CC. So there's a certain amount of common sense when you look at this. You look at the percentages of contributions, you look at various other things. If they've made huge contributions that are similar to what you're working on, you might choose to add them on CC in the hope that they will help you review things. In these cases, near the top are people who have done multiple commit signing. So that's people who may contribute to the subsystem in other ways by signing commits. Again, look at the history, look what they've worked on and decide whether they're a useful person to CC. This is just hints and advice, and particularly the stuff that's been extracted from Git is people you might choose to CC if you think it's beneficial. And ultimately, that's a judgment call. You'll start to get the hang of it over time. Discussing with mentors and experienced colleagues is another way to refine your capabilities there. But that's what comes back if you put a whole patch in. But you still get the very clearly stated, this is the maintainer, this person should go in the --2. At the bottom, you always get the mailing lists, people that you should add there. And then people in the middle are a judgment call. In my case, I'd be very tempted to have a look at Stephen, Boyd, Andrew, Alim, and Jean and see if they are all signing the same thing or if they're signing different patches. If they've been signing different things, I might well add them on CC. That's patch posting. So the next stage after that is waiting for feedback. So we've posted the patches and we're waiting to see what happens. First thing we'd like to say about feedback is that maintainers may be in a very different time zone. They're also very likely to be busy. So expecting a response after an hour is very much unfair to those maintainers. The best summary of etiquette we could offer, I'm almost tempted to say 2 weeks here, to be honest, but if you get no response after a week, you probably won't cause any offense if you resend. I personally don't resend unless I get no response after 2 weeks. There are also some situations during the merge window that we'll discuss next week where you wouldn't send within a week. So during the merge window, maintainers tend to be very busy. So if they ignore your patches for the 2 weeks of merge window, that's fine. Wait for them to have waited a week when the merge window is not taking place. But we'll discuss that in more detail next week. And obviously, you have put code out for review. It will be reviewed. That's the point of putting it out for review. You may well get tough questions back. You'll be expected to justify why you did it in a particular way if it is unexpected, or why you're doing it at all if it's not clear that what you're doing is even useful. That's what the whole currently this is doing this and it's bad because this pattern is about. It's about answering these questions so you don't get explicitly asked. If you're asked questions, you should give detailed and direct answers. Do look for questions that are really requests to make a change. So a question like, have you got the locking right here? Is a good example of a question that really means, I think you've got the locking wrong, go and double check. And so it doesn't necessarily mean describe your locking strategy. It means review it, comment, and so on and so forth. So questions may not actually be questions. They may be effectively hints that you should read a bit more closely. It is possible to create misunderstandings. You know, if maintainers will make mistakes just like anybody else, either by misunderstanding the hardware or going too fast or being too busy. So if the response doesn't make sense, yeah, it's an email. You can email back and say, this doesn't seem quite right. I think this is what's happening and it's okay. And finally, be aware that maintainer is expected to maintain look and feel of the subsystem. And some of the changes they ask may appear to be cosmetic, either lining things up differently or changing variable names or putting things in a different order. Certainly don't take that as a judgment of your skills. And also be pragmatic. And here, what pragmatic means is your goal is to technically and socially influence things to land a change in the kernel. If somebody has asked you for cosmetic changes, it is usually much, much quicker to make the cosmetic change than to discuss whether or not the cosmetic change is a good idea. You will be more productive upstreaming by just making the change and getting on with your life. Much, much the quicker thing to do. So while there are places you could say this is less clear because if it's genuinely something you feel is a mistake, you should push back. But if it's a matter of taste, then accept the fact that the maintainers' taste, they're the people that have to maintain the code going forward. So applying cosmetic changes is pragmatic. It's much better than debating whether it's a good idea, which simply creates longer circles to work with. And then finally, if you can't make head or tail of a comment, if it doesn't make sense, you always need to do a little bit of effort to try and understand it. But once you understand it, you should be in a position to ask for clarification. And there's an example of that in the there's an example email showing that coming up shortly. So addressing feedback. Firstly, be aware patches with version numbers exist for a reason, and that's because a lot of the time people do redo their patches. It's normal. Getting into version 4, 5, 6 is nothing to be ashamed of. If it's complicated work, getting into version 20 is not unheard of. You know, high patch numbers are not a problem as such, providing you are accepting feedback and not ignoring it. And more than that, if you get feedback, it's a good thing. That means that convergence is starting to emerge. If somebody's asked you to make a change, rather than that's a terrible idea, go and do something else, that's actually evidence that convergence is starting to happen. As a maintainer, I tend not to send out reviews while there's lots of active comments going on. I wait for the comments to die down and see what comes out the other side. So be responsive to feedback, not too responsive. In the sense that you don't want to revise a patch set every day or every hour because people start to drown in email. You want to leave it a couple of days, maybe a week between pushes of the patch set. But when you do, you should be responsive because unresolved feedback that has been shared and you have not acted on will almost always mean the maintainer does not accept the patch. To the extent that as a maintainer, if I see a lot of feedback, I don't even queue the patch for later review. I delete it and wait for V2, knowing that that feedback will be resolved. So yeah, if there's unresolved feedback, your patch is not going to be accepted. So you should answer all feedback quickly. And a lot of the time that does just mean saying, thank you for the review, I will make these changes. That's all you really need to send. It's appreciating the reviewer and showing that you've read it and you're ready to do the next bit. If it needs additional discussion, if you need to push back on view that you don't think makes sense, or you need to understand more about what's being said, discuss it without too much delay. Obviously, you have to spend time to educate yourself to make sure that you are not overlooking something, but at the same time, you know, a same day or next day reply makes the conversation with the maintainer flow better. That golden rule that we put up a couple of slides back, maintainers are the only path. So you are going to have to resolve the feedback to move forward. Ultimately, and additionally, it's not only maintainers who review your code, you'll also get reviewers passing by. But if you reject or ignore reasonable requests from reviewers, like I say, the maintainer will probably, in this case, literally ignore your patches. You know, in the sense that if there is feedback that has been sent by reviewers, I tend to delete that particular patch thread and wait for the next version to come out, because it saves me the effort of having to review the code again when there's pending changes. So that's one of the few changes where the ignore really does mean ignore. They've probably deleted your emails and are waiting for the next ones to come through. But in general, when you're working with feedback, you should be looking for that positive way forward, even if it's slightly more work for you, even if it is pushing in a direction that you don't personally care about. Gaining consensus is the pragmatic way to get patches accepted. So, simple, comfortable way to work with somebody. This was a very simple thing. This was a feedback that they would prefer capitalization of the words in the commit log. You don't push back on capitalization, you just do it. You say will fix, and then you send version 2 of the patch set. That's all you need to do. So you take note of the questions, the changes that we made, you let other reviewers take their turns as well, and then in a couple of days, you spin around and send out a new patch set. You certainly do not ignore comments and send a V2 of the patch that ignored the previous comments. If you do that, this is the nicest reply you might get. This is genuinely a maintainer who is being kind to a contributor, possibly because they're new or they've not met them before. Just says, to further repeat my previous review comments, bam, do not ignore review comments. If you have the habit of ignoring review comments, then nobody will bother to quote their previous replies. They will just say, there was outstanding feedback from V0, please address V1, please address it. And it's your job to go and find the emails. So this is the nicest reply you might get if you ignore comments. You might get slightly more assertive replies, shall we say. And this is that example of clarifying. It is just email. You are just emailing other people who will email you back. The fact it's a technical subject and you've never met them, it's still just exchanging emails. So in this case, we had a couple of things in a device tree binding document. And the device tree maintainer has said this specific value of the phi specifier shouldn't matter to this binding. What should matter is what it logically corresponds to. And the assumption in this reply was that this is something to do with phi reference with parameter 0. So the reply is quite reasonable. I'm not quite following this. Do you suggest that I drop the value 0? In the binding, I need to do this. 0 is for starter. Can you explain more? So that's not just saying, I don't understand, please give me more information, because you need to demonstrate the effort that you've taken to try and understand, or to help the maintainer latch on to where the disconnect, the misunderstanding is. So this is an additional bit of information here, asking if that is specifically related to the fact that we've mandated a parameter 0, and whether it's right or wrong. And I believe from the, I haven't read this for a long time, this thread, but I believe that that thread then resolved as the exchange was understood. So it's perfectly okay not to understand, but you don't just say, I don't understand this. You say, I've tried to understand this, I can't make sense of it. This is why I've done it this way. Can you cover it some more? That's a good example of how to seek additional feedback. This is one that I might leave you to think for yourself about. This was a reaction from a very passionate developer to feedback that said, you have to use device tree, I'm afraid that Allwinner's proprietary solution will never be acceptable to the kernel. And what you get back is not a technical discussion, it is a please state that you are happy for Allwinner socks not to work, basically. This is not the most effective way to technically and socially influence maintainers to accept your code, in my opinion. So yeah, this is quite a famous thread. It's somebody who's excessively passionate, and they are a hobbyist in this particular case, I believe. So it's somebody with a great deal of passion, who hasn't taken a keyboard break, is the best way I can put it, and might have benefited from it. Okay, so how to upstream. Once you had your feedback, you accept the feedback, you adopt the feedback, you make changes, and you resend all the patches in the series, even ones that haven't changed. You have a change log that you put in the cover letter or in a comment section in a patch that's standalone. But you do provide a change log. The change log should be saying what you have changed. And without a change log, it can be very difficult for reviewers to keep track of what's changed within a patch since they last saw it. It's also important that you increment the version number. So patch v2 if it's the next one, or you increment against the previous number. And do be prepared that there may be additional rounds of comments. It's not a one-shot version 2 ship. It's a patch 1, feedback, patch 2, feedback, patch 3, feedback, and it may go through multiple cycles. So the types of comments that you might receive. This is probably the most dominant comment, which is a request to make a change or a fix to the patch. So that's the most common type of feedback you're likely to receive. And it often, not always, but it often means that I don't think there's a problem with what you want to do. Most of what you've done is okay. There's just some small details that need to be improved. Maybe, broken error paths, or adopting a better API, or KZalloc or devm KZalloc, or better APIs than kmalloc, because they can't leak information. It might be about fixing coding style. It might be a better idea about a particular piece within it. The test for all the changes and fixes that come through is that if you can live with it, if you don't have to believe it makes it better. I mean, quite a lot of the time it will make it better, but it doesn't matter if it makes it better. It matters whether you can live with it. That's how you build consensus. So if you can live with it, just say, yeah, fine, I'll do that. Put it on your list, fix it next time, and resubmit it. That's how you handle requests for changes. You make changes. You can, as we've discussed, push back where the change is not going to be helpful or there's a mistake in the reasoning. But in other cases, the most pragmatic thing to do is to make the change and move on. The reason I labour this so much is this little person dragging their ego around on the right-hand side. You will have crafted this code. You will like the way you've expressed certain things. You might have certain particular idioms that you like to use in C that other people find hard to read. You'll be asked to change those. And if you can live with it, the best thing to do is to let your ego go and make the change. That's the pragmatic way to achieve the consensus you need to do your technical and social influencing. Other types of comments you might get, positive cheerleaders. So your code and some of the ideas behind it may get support from people who are well known upstream, have a reputation. That can help others to adopt it. And in particular, if there are people who are sort of unhappy, but not entirely, this is not about who's the biggest troll or anything like that. But if you have people who disagree with the general direction, but aren't quite sure or think maybe you could do better, the presence of positive cheerleaders will quite often give, help build consensus because those cheerleaders have respect. It's not they're not willing to argue. It's usually that the positive cheerleader with influence is respected enough that people second guess themselves. So any public support that you can get is valuable. And conferences are a particularly good opportunity to discuss with people if what you're doing the right thing. It's not your goal to go to conferences and try and collect pet maintainers, if only because that won't work and it will probably backfire on you. You're in a social setting, be social. But you can ask for advice. You can ask for, is this the most effective way to do something? And it may attract their attention. It may cause them to have a look at the patches. If they like the patches, it may even cause them to give you that positive feedback. So this is something to approach with care. You don't need to use conferences and other techniques to gain access to people. But if you are good at social networking, and not all developers are, it's a tool that you can use if you use it carefully and you remember that as a social activity in this particular setting, you do want to socialize when you get social time with maintainers. You don't want to always have an agenda and be trying to collect supporters, because they might not care about your subsystem. They might not care about what you're working on. So questions and ideas and feedback is a better thing to be discussing. The other type of comment that will come up quite commonly is some version of ACK, whether that's reviewed by or act by, or basically a comment that somebody says that this code looks okay to me. We'll discuss again tags next week. But these are strong signals of support of your work, saying that you believe that it's ready to go in the kernel. Maintainers do spot these things. They keep track of the reviewed bias, and code with reviewed bias is more likely to land than code without of it. I mean, a maintainer is still responsible and can refuse to accept code even with reviewed bias. But they're basically good comments. They are signs that somebody else cares about your patch enough to review it. So they're very, very helpful. They are a sign of progress during review. And one of your responsibilities is to collect tags that are shared with you. And when you revise versions of the patches, you have to add those tags back, which again, we'll discuss next week when we talk about tags. Now, this slide is one that we have to put up because some people are concerned about difficulties they might have upstreaming. I mean, the biggest difficulty isn't on this slide. The biggest difficulty is being ignored, not receiving any feedback at all, which is the subject right at the end next week. But the other thing that can come up is feedback where somebody has a pet change that they like. There's a particular change they advocate for, and every time they get the opportunity in particular patches, they will advocate for that particular change. That's less common these days, but it does exist. You might occasionally experience people with hidden agendas, as in they want to land a different approach, maybe haven't published it yet, and they just want to get in the way while other code comes through. The biggest, most common thing I think you will see is bike shedding. So bike shedding is based on the observation that you do not require any architectural skill or practical skill in building bike sheds to have an opinion about the best color to paint the bike shed. Green is an excellent color. It sits nicely. It'll sit in the landscape beautifully. Green is the right color to paint the bike shed. It's a contribution you can make without actually detailed understanding of what the bike shed is for and how to build one. And the effect is essentially to derail discussion by focusing on unrelated things. And in particular, of all the difficulties, bike shedding can happen in accidental ways and well-meaning. So you should still use the filters you have before. Can I live with this? Is it something I want to change? The problem appears when you get multiple bits of inconsequential, contradictory feedback. 3 people saying the variable should be called this, the variable should be called this, the variable should be called this, or the variable should be called this. That's a good time to reply and saying, I've listened to all the comments about what the variable should be called. I propose calling it this. Does anybody object? There's no point in calling it out as bike shedding. You can occasionally, but you might trigger some hostile replies by calling it bike shedding. But effectively, that's when you want to use non-technical email to build the consensus. Say, I've listened to everybody. I think this sounds like the best suggestion so far. I'm going to adopt this unless somebody pushes back. That lets people be heard, acknowledges that you've heard them, and will hopefully close down the discussion so you can focus on the more consequential matters. There's then some white space before we talk about trolling and flaming, if only because trolling and flaming is very, very rare on mailing lists these days. The best thing to do for trolling and flaming is generally to not reply, unless they're the maintainer, which shouldn't be happening. You shouldn't see that. Generally, they're on a public mailing list. Their behavior will be observed by the other parties. If there is a technical aspect inside the flame, reply to the technical aspect as you normally would. You either push back if you have to push back, or you accept the change if you have to accept the change, if you're willing to accept the change, and move on. You can just act the bit and ignore the flame. Or you can ignore the thing totally, or you can put it in, but they're pretty rare. And I have this rather obscure graphic of a squirrel at this point. So to explain, this is a grey squirrel. And in the UK where I live, the grey squirrel is an invasive species, and it has resulted in the massive population decline of the native red squirrel. However, the grey squirrel is beautifully cute and a wonderfully a pleasant creature to watch scampering around. And most of the red squirrel population is that it can digest acorns, which native red squirrels cannot. And it does carry a certain disease that tends to affect red squirrels more than grey squirrels. So it has no bad intents. It is not a bad actor. It is a perfectly pleasant creature trying to make its way. Yet you see the red squirrels decline. So what I really mean is when you see some things that might be difficulties, you should always give the benefit of the doubt. You know, they may not be trying to mark your patch. Have a look, find out what they contribute, find out if they put this in and most people change it because it's a worthwhile change rather than somebody's hobby horse. Don't assume the hidden agenda unless you're getting multiple feedback that makes no sense and you can't see a reason for them to be pushing in this direction. And then you have to ask, why is this direction so important? Now, I've talked about bike shedding and so on and so forth. So don't assume bad faith on actors taking part in things. You can spot these things and try and mitigate or try and find out if it's true or not. So these difficulties may come up, particularly bike shedding. But do not assume bad faith. Do not go looking for difficulties. Assume that people are contributing good faith, and the vast majority of all the people you will encounter are working in good faith. So we have to talk about these difficulties, but remember the squirrel. I know it's weird. Remember the squirrel. Remember that this is not the normal case. This is the exception. The final type of comment, I think it's the final type of comment, yes, is the knack. So the knack is the not acknowledge. It's the opposite of acking a patch. It's basically explicitly saying, and it's usually from somebody quite influential, to say, I think that if this patch is applied, it is bad for the Linux kernel, period. It's quite an unpleasant experience to receive a knack. I have received a knack on one occasion. It does create that visceral response. Why? It does create that visceral response. It is a very, very good time for a keyboard break. And then you have to think about what to do. And if it has been knacked for some reason that you can change or fix, that's fine. You can make the change or fix or adjustment, and then the knack will likely be withdrawn if you can address it. You can discuss with the person knacking to try and find what they might accept. Ultimately, however, if they've knacked for some fundamental reason, like all-winner board support is inappropriate, you have to use device tree, then you don't have any real choice. Assuming the knack is from somebody influential enough that the maintainer will not accept patches with the knack present, then you are going to have to rebuild to start again. The best thing to say is consider what happened. Do discuss with the person knacking what their problem is, find out why, make sure that whatever you build alternatively does not suffer from the same problem. And then only advice is to come back stronger next time. I'm going to add that in my case, I have experienced a knack, but it was one that I could fix. I didn't have to make fundamental changes. I just had to make the two subsystems to coexist in a better way. And that was enough to get the other maintainer to allow the code to be delivered. So again, these are very, very rare. Don't run in fear of the knack, particularly driver writers. Creating a new driver, which is usually most people's first upstreaming experience, you're very unlikely to walk into a knack. But that's what it means if you receive it. It means basically somebody is saying that they don't think that the code should be applied in its current form and possibly in no form. So how do we understand progress? What I mean by understanding progress is when your manager or your project manager says, are we done yet? How do you answer that question? So in the early stages of this process, managers and PMs and developers do intuitively understand how to measure the progress. To the point at which you share the patch on the mailing list, you can make a classic plan. I'm going to do this much review. I'm going to have to do this much rework. I'll then do some testing and I'll ship it. I'll send it to the mailing list. That's something that there's lots and lots of different processes, not all the same, not all as reliable as each other, but there are lots and lots of ways to try and measure progress along that path. Once you've posted to the mailing list, you are waiting for feedback. There is no particularly useful work that you can do, given that you shipped the code when you believed it was finished. There's no particularly useful work you can do to make that land any quicker, other than doing a resend after a week and a half, 2 weeks, if there's no responses. We will talk about the kernel cycle and the merge window next week, which will help a little bit understand progress. But ultimately, once you've put out a review, the amount of remaining work is open-ended. You don't know how many changes you're going to be asked to make. You don't know when you're going to be asked to make them. You don't know when your code is going to land. So in companies that do a lot of upstreaming, there quite often is an alternative kind of project planning process that comes through. You end up with tickets that can be put into the under review state. Project managers do understand that in review is an ambiguous length of time, and they expect maybe you to point out when you've resent and to say in the next kernel cycle that you've resent, and they expect maybe 10-week updates after that point. So engineers can help this by looking at the review comments and making a guess. So it's still the case that an unexpected review comment may change the flow, but if you've had a review by the maintainer that's asked for some changes, there's a good chance that after you address it, the maintainer is going to pick up the patch. So saying I've had the maintainer review it and they seemed happy does mean that you're quite a long way through the delivery process. If you've had a single patch from somebody who's not, a single feedback from somebody who's not in maintainers, who has asked you to make a whole bunch of coding style changes, that's probably a sign you're near the beginning of the process, because somebody who is not the maintainer is doing a review and finding lots of problems. So yeah, you can make a guess to some extent. And then finally, once the patch is accepted, once the maintainer applies the patch to their own tree, again, then you start to have a roadmap that makes sense. You can look at the kernel development cycle that we'll discuss next week. You can work out when that maintainer will be sending a pull request to Linus, and then when you can expect it to arrive in the Linus Torvalds tree. It's still the case that after a maintainer has applied a patch, they could yank it if it turns out to have bugs. So a patch being accepted does not guarantee you've completed upstreaming, but it's the point at which you would probably change the project management status and say, this is now expected in this kernel, this is now expected to arrive in this kernel, and absent problems, that's what would happen. So don't forget, just a reminder of some of the things we talked about. Interaction with Upstream is a social activity dominated by sending email and lubricated by things like IRC and conferences. People that the maintainer know and have had good experiences with do get more slack. They also get more opportunities to kind of ping on IRC and ask for informal advice and things like that. So it doesn't hurt if people recognize your name or they've met and remember you. And to be honest, just quietly doing a good job, especially if you stay working in the same subsystem for a long period of time, is enough to start building your reputation. Doing a good job won't be noticed by Linus Torvalds, but it will be noticed by the local maintainer. Contributing to code review, once you've gained enough experience of code review culture on the mailing list, will also mean that maintainer notices that you are doing reviews and they feel supported, and they recognize that you're doing good feedback for things. So, there is a lot of case that, although I've talked about conferences and networking and everything else, just getting a good job done can be sufficient to start developing your reputation within that subsystem. And then finally, as I've said, upstreaming is for most people a positive experience. Most contributors are earnestly trying to make the kernel better. And because they're all technical people striving to do something complex and interesting, you tend to get interesting problems. But they still don't care what your schedule is. Okay, some final thoughts before we dive into the worked example. Maintenance. Is this just one or two? Yeah, just one. After your code lands in the kernel, this is just a sort of thought for you to think about. You can, in principle, walk away and work on other things, and you probably will. But your code's still in there. You're still recorded as the author. People who run get maintainers on your driver will see your name, and they'll probably CC you in it. And it's a very good idea if somebody wants to make a change to a driver that you've worked on, to look at the change they want to make and share a reviewed by if it looks okay. If somebody makes a change to a driver you've worked on and you still have the hardware, sending a reviewed by and a tested by is even better, because it shows that you don't think the code has been damaged or regressed. So people will still involve you in the development process after you've moved on, and taking part in that again is a good thing for your reputation, to show that you are not just throwing code over the wall and then running away. It's good for you and it's good for your company's reputation. So it's certainly worth making sure when you have project manager involvement that the company does continue to support you in emailing about products that you've already upstreamed. It's not going to be a huge part of your job, but taking part in those reviews is very, very good for the company reputation. Okay, and while I have threaded this together with kind of the Robert's email thread and a few other bits and pieces, I do want to bring together this finally in with a worked example of a specific example. Before we do that, a quick summary of where we've come from. So talking on mailing lists is a social activity. And I did mention RFCs in passing. I want to just amplify on that a very little bit. When you've moved on to another company, so this depends to some extent. Let me read out the question, sorry. It's what happens if we've moved to another company or community and we don't have access to email? Ultimately, those mails will bounce. There's nothing you can do about that. Some people will add themselves to maintainers, and so that specific drivers are recorded, and you're basically saying, by adding yourself to maintainers in the patch, you are actively saying that I plan to take part in this in the future, and I'd like to be notified when somebody changes this piece of code. So that's the way that gets handled. If you've put it in maintainers, the reason you put it in maintainers, it allows you to send a patch in the future to change your email address. So if you're relying on the Git history and you move on, you've moved on. If you put something in maintainers and you move on and you want to keep working on it, then you can change your mail address to the next community that you moved on to, or a kernel.org address. Similarly, if the company chooses to do that and you intend to leave and you want to hand over the responsibility to a former colleague, you can send a patch in to change maintainers to put their email address in instead. So so that's the way that will get addressed. So the idea that when you move on, if you've put something in maintainers, you can update it. Otherwise, you are just moving on. Finally, you can put a kind of watch on. So one of the things I do one of the things you can do is subscribe to the mailing list where all the traffic should be going, and watch for your old email address. And then you will arrange to receive things that have gone to the mailing list. Sorry, let me try that one again, because that one's a bit weird. Although you no longer receive the email, you can subscribe to the mailing list where everything should be copied. And one of the filters you can apply is your old email address. So if you want to continue watching it after you've moved on, you can use the mail list and a filter to pick out stuff that's gone to your old company address and handle it from your new address as you need to. So there are definitely techniques you can apply. Some of them are going to be how much you want to. I mean, when you change company, the fact that you have less time to spend on other things, you may want to keep building your kernel reputation at home to secure your next job, or because you enjoyed it. You may want to just move on and leave it to your colleagues. So I hope that gives you some options. So into our worked examples. Sorry, not worked examples, the summaries. So we have RFCs. I hinted at RFCs a little bit midway through. They're an excellent way to ask technical questions. They're an excellent way to ask questions before you get to the next stage. For example, if you're very, very unsure about how to proceed, you can use it. Code talks in the kernel community. So asking via RFC is also a good way to have a stake. You're showing I've done enough work to be worth spending time with. And the final thing with RFCs that we mentioned is that doesn't excuse you from meeting coding style, making it possible to read your code and everything else. Taking a poor quality downstream driver and an RFC saying, what should we change, is a good way to get more feedback than you could possibly absorb. Not all of it good. So RFC should still conform to coding style. They should be still the best output you can. They're just a way to frame a question. We've mentioned the documentation. You should be reading the process documentations and making sure that you're happy and comfortable applying these things. You should make sure you use email in a specific way Upstream expects. We didn't spell this out specifically. We pointed you at Git send email, and I talked about working with colleagues to make sure you can send plain text emails effectively. But you definitely do want to be able to use email in a specific way the Upstream expects. We talked about your name and your employer's name and how you don't want either of those things to come to reputational harm. We've talked about the importance of taking comments seriously. Feedback matters. Feedback is something of a currency in the world, in the kernel world, because it is what lubricates the kernel process. Having reviews, having comments back and forth is how the upstream process works. So you need to take those comments seriously. And the maintainers, or a maintainer, is the only path to get code landed in the kernel. Okay, so as a concrete example now, we're going to look at a specific bit of watchdog upstreaming from several years ago. I'll also call out the differences between what actually happened, because this is a real story. There is what did happen then and what might be expected to happen now if you've got device trees to worry about. But first up, we have a watchdog, and we need to make sure the patches are logically split in a sensible manner. And I've picked out kind of 5 different ways you might start to pull things out. So first off, if it's new hardware and it is managed by device tree, you will need to create some device tree bindings, which is basically documentations of what the device tree properties mean for that particular piece of hardware. And that goes in a separate patch because there are 2 different groups that need to review that. One is the device tree team, who will make sure that it conforms to the device tree coding standards. And the other is, I'm going to say, I suspect this is Wim van Sebrok. I'm afraid I can't, I suspect it's Dutch and I don't know how the vowels, the V and the W sound. But Wim van Sebrok, who is the watchdog maintainer, and they would provide the domain expertise about watchdogs. And so that patch would be reviewed by both teams. One would give the other the approval to apply it. And that would then be separated from all the other activity. There's no need to combine that with any other patches that make C code changes. If you had somehow managed to create an innovative watchdog that required framework changes for your driver to use, you would probably pull those out in a separate patch. So if you had to make foundational changes to the watchdog framework to make your driver work, you would pull out as a separate patch so that Wim and the other watchdog maintainers and reviewers could handle that separately. It's hopefully a small change, it's well contained, it's got a very clear explanation as to why this change is necessary, and they can review it independently of your driver. It would be uncommon, so it's not usual to make framework changes. Most drivers you write are going into mature, feature-rich subsystems where you don't need to make framework changes. But if you do need to make framework changes, you definitely want to pull them out into separate parts. After this, you will have the driver itself and any build system plumbing. So that means the driver C file, makefile and kconfig changes. In one patch, that would be expected to be reviewed by Wim. If you need to change the def config, so you don't always need to change the def config. If you are adding a embedded centric driver, you may well not need to change the def config. But if you would like the patch, if you would like the driver to be enabled by default in a def config build, you might need to change the def configs to permit that. That would be mostly for the attention of either the architecture maintainer where the def config lives, or maybe the ARM SOC team, because there are lots and lots of def configs on ARM32. And then finally, there might be a patch to effectively activate the driver by changing the DTS files in /arch arm boot DTS or arch arm 64 boot DTS to actually cause the driver to bind when you fire up. So 5 different categories. If you had multiple framework changes, there would be multiple patches. If you had multiple DTS additions, you probably would put them all in the same thing, assuming they're all for the same architecture, sub-architecture, they're all Qualcomm ones or they're all TI ones, all NXP ones, you would probably put them in the same patches for the DTSs. So you split things up, and we pick a particular split up, and that would be the idealized split up. And I have here the actual split up, which was super simple. It is a watchdog, which is just the C file, and a separate patch to enable it in the def configs. And the reason for that is this particular hardware at this particular time didn't require DT bindings and everything else to be upstreamed to make the driver useful. For most ARM driver work, you do need to add a DT binding. So if this example had needed device tree changes, you'd have seen a patch structure much more like this. So there would have been a adding the DT binding documentation, add the watchdog driver, add the configuration, and then modify one of the device trees in Arch ARM boot to enable the driver to bind properly. So that's what it would look like, and that's the pattern that you will see over and over again. So I'm going to send you out as lab exercises to subscribe to some mailing lists and try and learn from them. And this is the pattern you'll be looking for, probably without the def config change, so probably without this third patch, but you will see over and over again, add the binding, add the driver, update the DTSs. That's a very, very common pattern for a patch series. So you can go and look for those in the real world when you finish training. So for now, we have this simpler patch system that fits much better onto my slides. So it's only 2 patches, plus the covering letter. The covering letter is dominated, it uses the same name as one of the patches. That's quite common when you're adding a driver, because that's the real goal, adding the driver. The DTS bindings and the other things are ancillary, so you might well often call the series after the driver introduction. We use git format patch --minus cover letter to produce the 0th thing. We've pushed it out to this directory. We've added appropriate 2s and CCs to the maintainers that we want to copy and to the mailing lists and reviewers that we want to put on CC. And we've used a git ref to say, I want you to go for all the patches between 4.3 RC1 and the SHA1 of patch 2 of 2. How you express the git rev is up to you. I personally use negative numbers. So if you put -2 in here, it would go to the head of the current branch and give you the top 2 patches. So -2 would give you exactly the same results as this. And the result is 3 files in the temporary directory that was supplied: the cover letter, watchdog patch, and the def configuration. So I would always eyeball these 2 patches to make sure I haven't made any mistakes, and then I would put them through check patch and other quality checks. And then we need to write the cover letter. So the cover letter looks a lot like this. This is the real cover letter. Everything from Marcus Mayer downwards is auto-generated. So this set at the bottom is called a diff stat. This diff stat basically shows you where the new lines are being added or removed. So this is saying that there are lots and lots of new lines added, lots of new lines of code in here. We've added a line to the make file, 21 lines to the def config, to the kconfig file, and 3 lines to the def config. And maintainers can use those to kind of feel how big the patch is, how much review effort it's going to be. It's very, very useful to have diff stats in there, which is why git format patch generates them for you. Git format patch will leave a placeholder in the subject for you to edit, and this sentence here again is left as a placeholder, and you have to fill it in yourself with the information you need to have. It's a very good idea just to have a separate C file, a separate text file that stores what you intend to put in the cover letter, and then just use your editor to paste it in just before you post the series. The watchdog driver itself comes through, so we've got a good subject. The description can be fairly brief. This commit and support for the watchdog timer for this family of socks, because that's what it does. There's not really much more to say about it unless there was something weird going on. In this case, you can see it's been signed off by Marcus. It's also got a reviewed by. So what would have happened in this case is Matt would have done an internal review of Marcus's work prior to putting it on the mailing list. It's a good way to tutor new developers, is to ask somebody else, quite often the developer themselves asks, is to ask somebody else to review your work for you and give you feedback similar to how external review would be done, but done internally with people so it's a bit more comfortable for the first experience. So Matt would have done that, and we're recording the fact in this reviewed by that Matt has reviewed the code and believes that it's adequate to go in the Linux kernel. So that gets sent on day one because Matt did the review ahead of time. You don't always want to add this, it's not necessary, but that's simply a reflection of what actually happened in this case. So the feedback you get, this is the wrong choice of return value. And that does matter because E again has a special meaning in the C library. You can see that Alan has mentioned here that E again has fairly specific semantics around signals. It's a big deal. Getting E again wrong is a big deal. So that's very valid and useful technical feedback. So Marcus says, well, yep, I'll change that based on Gunter and your comments. So that's an acknowledgement that somebody else has also reviewed and we need to fix it. So that's the variant of the ACK or the will fix or everything else. There's lots of different ways to spell it. That's how Marcus chose to acknowledge the feedback, and he made the changes. And he sent out version 2, and he sent it out with a change log, which you should always do when you send out new versions of patches. And there's actually been quite a lot of changes, so it was quite a significant amount of review that has improved. Comments about the delays and the retries, and all these things are basically been refined and put into a better state. And eventually, the patch series gets accepted. You will notice here that the number now is version 5. So there has been several rounds of review this has gone through. You can say you don't always land changes at V2, even with lots of changes. So it's got to V5, and you get this unusual phrase, I've applied the patches, but without the debug part, because I'm still unhappy with it. So what's left is in the following patch. So basically, that's actually quite kind from the point of view of the maintainer. They could have just said, please send version 6 and rip out the debug and make it Marcus's problem. But I suspect we were getting near a release point and the maintainer wanted to get it done. So they very kindly just said, I'm not going to accept this code right now. Come back and argue for it later if you really, really want it, which is a prerogative maintainers have. You sending in your code, they are able to edit it and take it on. There's some formats that they would tend to add in the signed off area to say they've tampered with it. But yeah, it's absolutely, if they don't want to take the whole code, but they do want, it's quite rare though. Mostly they would expect you to edit it for you. I suspect there's been something in the history between Marcus and Wim as they've been talking about it through 5 patch versions that made Wim happy to do this. But yeah, it's been accepted. That's when it lands in Linux Next. It's when you might start to see it and when you can start predicting when it's going to arrive in the upstream. So we very close to the end now. This is the same slide that I put up at the beginning, and it has in bold the, this wasn't in bold before, that second point of view, the process of technical and social influencing. It's not that that first definition is in any way wrong, it's that it's incomplete, and that to understand how to upstream effectively, the second definition is a much more useful summary of how you can upstream effectively, to understand what you really have to do to be successful. And that is what you have to do to be successful. It's why we focused on this so much in today's talk. So the last thing from me is a quick comment about the lab sessions. So normally when we do training, of course, we set exercises that allow you to do technical things, and that doesn't really make any sense when we're talking about upstreaming, because creating, tiny little white space fixes and doing the mechanics does not really help you learn about technical and social influencing. It shows you some of the mechanics, which you could probably follow from a book anyway. So we want to think about upstreaming at a slightly deeper level. So I've got some suggested reading. First off is the process documents that I have alluded to a couple of times in the presentation so far. So you should read these. You should contrast what they say with what I say. You should be confident in what that material means over time. So you should read all of those documents. You could also read Greg Hartman's How to Piss Off a Kernel Subsystem Maintainer blog series. This is quite an old series now. This is a link to the last in the series, and they backlink previous versions. So this is a way to give you one link that you can work from. These are quite entertaining reads. It's basically all the ways that drivers have been submitted to him in a way that make them hard to review. And like I say, it's quite entertaining, and there is kernels of truth in it. The most effective way to upstream is to make it easy to review. So seeing how other people have made it hard to review can be an interesting alternative way to view it. I focus on the positives when I do this training. This is the way to focus on mistakes that you shouldn't make. Another resource that is worth looking at is a presentation from Greg Hartman in 2013 called I Don't Want Your Code. This was presented at Linaro Connect. It is quite an old video. This is one of the earlier Linaro Connects. The recording quality is reflected in that timescale. However, in my opinion, it remains very relevant, and it isn't just useful. It's also historically interesting. So Linaro does not come out of this presentation looking especially good. We had work to do at that point. This talk provoked significant changes at several companies that were in the audience, most especially Linaro. So I don't think Linaro suffers from this problem as we used to. It was very much endemic in the way assignees were being handled at that point in time. So a lot of what we did to help correct things was to make sure we took better care of assignees. So yeah, it's an interesting presentation. It's along the same lines of how to piss off a kernel subsystem maintainer. It's showing what shouldn't be done. It's expressing some of those ideas about you're paid for this, you need to get it right, and gives you some idea of the approach that's being taken by some of the upstream maintainers. It should not scare you off. It absolutely should not scare you off, because it's basically describing mistakes that you don't need to make. And if you don't make them, there's absolutely nothing to worry about. So it's not there to scare you, absolutely not. And it's delivered with tremendous good humor. So although he's making important points about behaviors that should not happen upstream, it is with good humor. It is accepting the fact that nobody's perfect, and that occasionally these things will slip through. It's normal. So finally, I want to talk about learning by watching. So the other thing I think that should be done between now and next week's session is to join a mailing list, not Linux kernel mailing list, it's too high volume, not the ARM mailing list because it's also too high volume. Look for a subsystem that you have some experience in or interest in. So if you already know lots about I2C, join the I2C mailing list. If MMC is something that you find tremendously exciting, join the MMC mailing list. The goal is basically to see some patches flowing past. Look for the pattern I described with the device tree. Look to see who's doing a good and bad job of responding to maintainer feedback. You can also go backwards through the mailing list archives to do this, but I quite like subscribing to the list and letting the examples come to me rather than have to go looking. But yeah, that's the goal. You're watching, you're learning, you're seeing who's doing a good job. You're trying to figure out who the maintainer is by their actions as much as by the fact that you've seen their name in maintainers. You're looking for reviewers who are contributing. So it's just a good way to start getting examples of upstreaming in front of you so that you can learn from them. And this link, incidentally, is Minare, is a kind of concept of Japanese learning by watching. And I've probably done some cultural mistranslations as I've gone through it. So there's a link there to, it's my source for why I picked that particular word. But it is a very valid way to learn about upstreaming. It's just to watch other people do it and see who you want to copy. And that gets me to the end. I'll give just a few seconds, well, I'll give you slightly longer than that. If any further questions come in, I will address them at this part in the presentation. If no further questions come in, then we'll be winding up. For next week, we will come back and be talking mostly about tools and techniques. So this week we've gone through the general procedure, and I've kind of laboured quite heavily the philosophy of technical and social influencing. Next week we'll move on from that. We will look at tools and techniques that hopefully can make you more effective at upstreaming. So there's a question just coming about where to access the lab sessions. The slides we've sent you links to. The lab sessions for this particular training are non-prescriptive. So they are the 2 slides that I've put in front of you. There's materials to read, there's materials to watch, and there is this strong recommendation that your lab activity for the week should be to subscribe to a mailing list and watch the traffic in it, and look for the patterns that I've talked about. Look at how tags are being used, look for the sign-offs, look for the comments that are coming back from maintainers, look for how device tree patch sets are being handled. So that's the lab activity. It's not a sit down and write an exercise. It's not figuring out how to send an email with git send email. I don't think that's the key and most important exercise, key and most important lessons you can draw from today's talk. I think the better lessons are to actually look at how the social interaction happens by joining mail lists and watching what they're doing. So they're the final 3 slides of the presentation that we shared at the beginning. Possibly we can put that in the webinar chat again. So I can't actually, I need my moderators to help me with this bit, but we can put the link in the chat again to show that. So I don't think I can send it myself. No, I haven't got permissions to do that. I can put it up on the screen, but it's a bit of a handful to type. So the specific link is this one. So if you're very quick at typing, you can grab that, but like I say, hopefully we can get it in the chat for you shortly. The slides will also appear alongside the videos, just to add to that. So we will share, possibly in the next couple of days, access to the videos. I think that's also been discussed in the chat a little bit with people, and that will give you access to a video and slides side by side. But that will only be up for a limited period of time, a couple of months, whereas the slides, if you download them, you can keep for as long as you wish. Okay, and with that, I think we are done. So thank you all very much indeed for joining me today, and I hope to see some or all of you next week.